Hello everyone, today we are going to discuss about universal law of gravitations. From the chapter Gravitations we have already discussed about the Kepler's law, and after Kepler's law of planetary motions, next important topic is our universal law of gravitation, which is known as the Newton's law of gravitation. According to Newton's, there must be an attractive force between any two body in this universe. And if we discuss about any two body, let me take two marker, then there must be some force of attraction between these two body. Similarly, let me take a marker and a duster, then here also there must be some force of attractions. If we observe then for the small body, it is not possible to observe the force of attractions, but if you can give an example of planetary motions, that means all the planets are moving around the sun. In that case, you can observe the force of attractions. And according to Newton's, not only the statement, he gave an expressions, mathematical expressions for the universal law of gravitations. According to Newton's, it states that the law of universal law of gravitation states that every body in this universe are attracted with each other, every other body, and the force of attraction is directly proportional to product of the masses and inversely proportional to the distance between these two bodies. Now, if we take an example, here mass m1 is there and here mass m2 is there, and they are separated by distance r, small r. Let's take. Now, m1 is the mass of first body, m2 is the mass of second body. Then according to universal law of gravitation, the force of attraction is directly proportional to product of the masses, that means m1 and m2. And if r is the distance between the mass m1 and m2. M1 and M2 are separated by distance r. Then in that case, mass are M1, M2, distance are separated by r. They are separated by r distance. Then force is inversely proportional to square of the distance. Now, if we combine these two equations, let's take this is equation 1, this is equation 2. Now, combining these two equations, according to Newton's, force is proportional to m1, m2 by r square, we can write down, and force F is equal to, let's give a constant, g m1, m2 by r square. Here this g is called universal constant or gravitational constant, and this g value is equals to 6.67 into 10 to the power minus 11. Its unit is Newton meter square by kg square. So Newton meter square per kg square. This one is your universal law of gravitations. Now, according to your in gravitations, m1 and m2 are any two body. So let's take, if we want to find out the force of attraction between a body with respect to, or let's take moon with respect to earth, or any body with respect to earth, then in that case m1 is, let's take the mass of the earth, and m2 is the mass of the any object. Let's take small m. Now we can write down the force of gravitation is equals to g into capital M small m by r square. Here this r is equals to capital R. If the object is on the surface of the earth, then this one is radius of the earth. So we can write down this r to capital R square. Capital R is the radius of the earth, and its value is how much? 6400 kilometers. So in this case, G is constant, mass of the earth is constant, and R value is also constant, and you can find out the force of gravitation for the respective body. In this way, we can calculate the force of attraction between any two body or a body with respect to any body with respect to our earth.